Hello, my name is Santiago Martinez, and we're going to be reviewing the questions 4, Part A, and Part B for Exam 2. So, Part A is asking us to give the vertical asymptote of a given function, and Part B is asking us to give a horizontal asymptote of that same function. Our function is g of x is equal to 1 over x minus 3 plus 4. So let's start with our vertical asymptote at what point? So when we're talking about vertical asymptotes, we first make sure there's no removable holes. What that means is that if two terms cancel out after we simplify everything, and then we will apply our rules for our vertical asymptote. For this example, we have 1 over x minus 3 plus 4. Well, this term's not completely simplified, so we need to get everything into one fraction. So we're going to multiply by x minus 3 to this, our right side of the problem. So we should get 4 times x minus 3, and remember there's always an invisible 1 here, so 4 over 1 times x minus 3, and we should get 1, and make sure that is correct. This is actually a subtraction, excuse me. And we should get 1 minus 4x minus 12 all over x minus 3. There's a mid step of this where you could have 1 over x minus 3 minus 4x minus 4x minus 12. But the whole reason why we multiply by the most common denominator is to get one fraction. So we just skip that step here, but that is what happened. So we can condense this and make sure we have our problem correct. So now looking at this, we can combine like terms. So we should have negative 4x minus 11 over x minus 3. And our important part is this bottom part. So it's also important to note why this is going to be our asymptote. For rational functions like this, this is going to be x minus 3 cannot equal 0 because it's on the bottom of the fraction, and we can't divide anything by 0. So we never want it to equal 0. So we could do x minus 3 is not equal to 0 plus 3 will give us x cannot equal 3, and that will be our vertical asymptote as well. So we'll say up here, vertical asymptote at x is equal to 3. We say equals here because in this term, in this sense, I was talking about a restriction, which also happens to be our asymptote. And we say not equal, but x is equal to 3 when we're specifically talking about our asymptote, because that problem can be 3. So that's why our vertical asymptote sits at x equals to 3. Now, let's talk about our horizontal asymptote, which would be HA. And what's important to note here is that there's a couple rules that we can follow. So we're going to write an expression right here of a of x to the nth plus whatever or minus whatever all over b x to the nth. And the rules that we're going to write is if n is smaller than m, then our HA will be y is equal to 0. The way we think about this, right, is that if our numerator is smaller than our denominator and we're dividing by a smaller number or by a bigger number and we're dividing by a bigger number, that number is going to be so small, approaching 0. So no matter what, our asymptote is going to be 0 because we're going to forever be approaching 0, depending on what number that is as we scale bigger all the way towards infinity. Now, if we look at our second rule, if n is equal to m, then our HA will be equal to A over B. Just our two leading terms for both top and bottom, numerator and denominator, and that will give us our number, and that will be y is equal to that number. And then there's a third rule where if if m is bigger than n, right? So I misspoke earlier, when m is bigger than n, we're going to get no HA, and we will actually have a slant asymptote, which we won't cover, but in that situation, that's what we will have. I also want to highlight when I was speaking about n is bigger than m. It should be actually this way. N is bigger than m is the correct term or rule for asymptotes. Yeah. So if we are moving on to our actual problem and how this applies, we'll look at our simplified problem over here. Will do just fine. We'll look at negative 4x minus 11. And this term will be just that. And x minus 3. In this situation, we're just looking at this and this. So we see that this has a power of 1 and a power of 1. So we're going to just simply take a over b. And in this situation, there's an imaginary 1 right here. And we'll take negative 4 divided by 1, which will give us negative 4. So we'll have an HA at y equal to negative 4. I should box the whole entire thing. But yeah, so just remember when we're doing our vertical asymptotes, we are simply just taking the bottom after simplified and setting that equal to 0. If no holes, of course, that's also going to play a role in our domain, as we'll speak into a later video. And we're looking for our horizontal asymptotes. We look at our two leading coefficients and what their exponents are. If they are the same, then we'll do a over b. If the numerator is bigger than the denominator, then we have just a y equal to 0 asymptote. And if the denominator is bigger than the numerator, we'll have no HA. Yep, that was vertical asymptotes and horizontal asymptotes. Thank you.